Welcome back for day 2 of graphing linear functions. Today is going to take it one step further. We're not going to be focusing on is it linear or not, because everything today will be linear. And we're not going to be dealing with tables and such. We're going to be actually giving you equations.
But before we get started, we need to touch base with the EQ questions going forward. They're going to be more of a higher level thinking, and the explanation in your summary is going to need to be more than just one sentence going forward.
Because the likelihood of you being able to actually answer the essential questions going forth with the way we've rewritten them, you probably won't be able to answer it with a significant amount of accuracy if you don't use more than one sentence. So let's take a look at this first problem. We have a equals 3/2 x minus 6. If you remember from yesterday, we had y, this is in the form of y equals mx plus b, or that slope-intercept form. And remember, that means that this here is your b, and this here is your m. And we're going to deal with the b first, or your y-intercept, and then we'll deal with the slope, or m, second. So we deal with this being a -6. So we start by graphing -6 on the y-axis, not on the x-axis. And then because it's 3/2, that's a rise of 3, run of 2, not the other way around. So we go up 3/2, up 3/2. I could keep going, but I only need 3 lines. And so then I connect the dots. Don't forget to put the arrowheads on the ends of your lines like I've talked about before, because that shows you actually understand what a line is from geometry. The next type of problem that you'll see is going to be where it's in standard form. Remember, that's in the form of some number a times x plus some number b times y equals some number c. And so in this case, we need to solve for y. So in order to solve for my beautiful y here, I need to get rid of this 3x. So I'm going to subtract 3x from both sides. That gives me y on the left. I cannot combine 5 minus 3x, even though some of you still seem to think that you can. So then I'm going to write it in terms of mx plus b. It's a -3x plus a +5. So now that I have that, I can graph the +5. And then I have a -3 slope. That means down 3, forward 1, or to the right 1. Down 3, right 1, down 3, right 1. And then I can connect my dots. I apologize if my lines aren't straight enough to your liking, but you get the idea. Then we have to deal with word problems. Now we have Sally running a landscaping business. This table shows how she charges her fees for the time she works. We need to explain why this data set is linear. I'm going to give you a second to think about this and enter a response, and then we'll talk about it. All right, the reason why this is linear, remember, is because as we go up an hour, up an hour, up an hour, etc., we're going up 6 hours, or $6, up $6, etc. So therefore, because it has a constant rate of change, and I will allow you to ROC for rate of change, that would be significant enough as to why it is linear. Now, that being said, remember, slope is your rise or your y over your run or your x. So thinking in terms of time is always x, and everything else would be y. That means that for every hour we go up $6. So it'd be $6 over 1 hour, or 6 over 1 for our slope. Let's go ahead and graph this. We need a y-intercept. We always want to graph a y-intercept, but we don't have that. But it says that every time we go up an hour, we go back forward up $6. So that means if I go back 1, I go back to 0 hours, which means I would go back $6, which would take me to 2. That means that my y-intercept is 0, 2. And then we go up 6 to 14 and over to 2. And then we can follow our points here. We've got 3, 20, and that's probably good enough, although we have to, given our next step in the process with the estimation, we probably want to keep going. So we go 4 to 26, and then we go 5, 32, and 6, 38. And I'm going to connect my dots and draw my line way out here. And it says estimate the cost for 9 hours of service. 9 hours of service would fall right here. So our point would be, intersection would be right here. If I estimate here, here's 40, 45, 50. It's give or take about $55. Now the question always comes up of, can you just extend out the table and say, okay, 7, 8, 9, and add the money on? Absolutely. I just think when it says estimate, we don't have to do that much work. We can make an accurate estimate. What I need you to do now is give our 2 U-Try problems a shot. We have first graphing in slope-intercept form with y equals 2/3 x minus 4, and then graphing from standard form with y, negative 4x plus y equals negative 1. And remember to get it solved for y first. And as always, write your summary, bring your questions with you to class. The reason why I say write your summary now is because you have the skills now to do it before you even get to class.